All right, advanced math, looking at our rational roots test is what we did the Friday before break. So I know it's been a while. So basically, if I have a polynomial, okay, and I want to figure out where does it cross the x-axis, right? This was some function, just kind of drawing a function. If I wanted to find the roots, okay, that's what I'm trying to do here. And some of these factor, and so you can find it that way, but other times they don't. This one actually does factor a little bit, but we're trying to learn the method here of how could you find the possible places where it does. And so to do that, you use the first term and the last term in the polynomial. So this is a coefficient of 1, and this is the last term is a 64. So what you have to do is list all of the different ways to multiply each of those terms. So I'll take the last term. Don't worry about the positive or negatives right now. Okay, so you got 1 times 64, 2 times 32, 4 times 16, and 8 times 8. Okay, those are all the ways to multiply to the last term, and then all the ways to multiply to the first term. That one's pretty nice, so it's just 1. Okay, then what you do is you put all the factors of the last term over all the factors of the first term. And this one's pretty easy because there's not that many factors. So what I mean by that is I'm going to go ahead and put them in order. So it's 1, 2, 4, 8, 16, 32, 64. Those are all the different numbers. And you do plus or minus. So it's plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, plus or minus 16, plus or minus 32, and plus or minus 64. Okay. All over all the factors, it's just plus or minus 1. Okay. So now, that's a little weird looking. So now what you do is you take each of the numerators and put them on all of the different denominators. In this case, there's only one. So I'm going to put this on top of that, and reduce. So it's going to be plus or minus 1 over plus or minus 1, plus or minus 2 over plus or minus 1, plus or minus 4 over plus or minus 1, plus or minus 8 over plus or minus 1, and continuing with that, okay. So then I reduce, and these are all over 1. So when they reduce, just go ahead and put 1 plus or minus. They'd all cancel out. But so we're basically looking at plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, plus or minus 16, plus or minus 32, and plus or minus 64. So those are all the possible zeros. Those are the places where that polynomial could cross the x-axis. Okay, let's try another one. F of x equals 5x to the third minus 2x squared plus 20x minus 8. Okay, and then from here what we're going to do is the same thing. So list all the factors for the last term. It's 1 times 8 and 2 times 4, and the first term is a 5, so that's 1 times 5. Okay, then list all of those factors. So you do the last term on top. So it's plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. Okay, all of the factors of the first term, so plus or minus 1, and plus or minus 5. Okay, so then I got to make some sense out of that and get some individual numbers. So now what I do is I take this number, all of these numbers, and put them over that one, and then do it again and put them over that one. So it's going to be plus or minus 1 over plus or minus 1. I'm going to put everything over 1 right now. Okay, and there's 4 of them. Right, and then I'm going to do the same thing and put them all over the second one. Okay, and then just list the numerators. So I just kind of listed all my denominators first. So plus or minus 2, plus or minus 4, plus or minus 8. Now put them on top of the 5s. Plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. Okay. Then simplify if you can. So all of these are just going to be plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. Over here, I can just do 1 plus or minus. So those are all the numbers that it could cross the x-axis at. So 1 and negative 1, 2 or negative 2, 4 or negative 4, going all the way through that. Okay. All right, so the next thing we need to determine is, okay, so if those are the possible ones, how do we determine which ones actually are the ones where they cross? So we need one more additional step. So let's do another one here. So in this case, we're going to state the possible zeros, and we're going to actually find them. So we're going to find the zeros. Okay, we're going to find the zeros. So if I gave you something like f of x equals x to the third minus 13x squared plus 23x minus 11. Okay. So in this case, do just like I did. Take all the factors of the first term. Take all the factors of the first term. That's 11 times 1 and 1 times 1. So this one's really nice because there's not really all that many numbers. Okay. And then I'm going to take all the factors of the top one over all the factors of the last one on top and the first one on the bottom. So it's going to be plus or minus 1 plus or minus 11 all over plus or minus just 1, right? So in terms of what are my possible roots, plus or minus 1 over 1, and then plus or minus 11 over plus or minus 1, and those reduce to just plus or minus 1, plus or minus 11. Okay. So how many different roots are there? They gave me 4. 1, negative 1, 11, and negative 11. Those are basically all the places where it could cross the x-axis. So I'm going to figure out which one actually is. So to do this, I go ahead and have to use synthetic division. So here's my coefficients. Make sure every power is accounted for. 3, 2, 1, and 0. So I'm going to say 1, negative 13, 23, and negative 11. Okay. And I'm going to go ahead and start with what I think is the easiest one, which is 1. Okay. So I bring down my first number, and I multiply here, and then I add this way, multiply again, and subtract down, and then multiply across again, and I get 0. So remember, if I have no remainder, that is a 0, and it does factor, so 1 is a root. So there's one root. Okay. So now to make my life easier, when I do synthetic the second time, I'm going to use this polynomial here. So, and I got these other 3 options. Right? Negative 1, 11, or negative 11. So I'm going to go ahead and try negative 1. So I'm going to bring this down, and I get negative 13, and I multiply across, and I get 13. So that is not going to work because this does not add to 0. Okay? So negative 1 is out. So I'm going to rewrite that here. 1, negative 12, and 11, and this time I'm going to try 11. Okay, so now I'm trying my next one. So this one worked, this one did not. So I bring it down, and I multiply. Okay, bring it down, negative 1, and I multiply, and that worked. Okay, so I get 0. Now, remembering every time I do the synthetic division, everything drops a power. Okay, so the original question was to the third, and I do synthetic division one time, that's down to the second. So what I really have here is 1x minus that equals 0. Okay, so if I solve this, I get x equals 1. Okay, so the roots that I got were 11, 1, and 1. So I have a multiplicity, so these are my roots right here. My roots are my zeros. Okay, use synthetic division until you get it down to a nice easy part. Okay, let's do one more. So same directions, find the roots. And I'm looking at f of x equals 5x to the third plus 29x squared plus 19x minus 5. So list all the ways for the last term to multiply, and the first term, they're the same. So this is going to be plus or minus 1 and plus or minus 5. That's for my last term. Over my first term. Okay. So then I list all the combinations. So take these two numbers and put them over that one. Take these two numbers and put them over that one. So plus or minus 1 over plus or minus 1, and plus or minus 5 over plus or minus 1. And then now put them over the 5. Plus or minus 1 over plus or minus 5. And plus or minus 5 over plus or minus 5. And see if anything reduces. So this reduces to plus or minus 1, plus or minus 5, plus or minus 1 over 5. And this reduces to plus or minus 1. So it's the same thing. So these are really all I have here. So now I'll go ahead and use synthetic division here to figure these out. So I'm going to take my original polynomial up here, and so it's a power of 3. So after I do synthetic division, it's going to go down a power. So I'm going to list my coefficients. And I'm going to try 1. So remember, bring the first number down. Then remember, it's always multiply, add, multiply, add. So multiply these two. Multiply right there. And then 19 plus 34 is 53, and we can see that that's not going to work. Okay, so 1 did not work, so let's try negative 1. Okay, bring down the 5. Move this up for you. Bring down the 5, and then multiply 24, multiply negative 24, negative 5, multiply again, and that's a 0. Okay. So what this really means is, so that is one of the factors, negative 1. So what I really have here is 5x to the second plus 24x minus 5x, right? So I have that right there. So I could go ahead and just pop that into the quadratic formula, but I'm going to go ahead and use synthetic division one more time with that. So I'm going to try negative 5. With those coefficients, 5, 24, and negative 5, bring it down. Multiply, so that's negative 25, that's negative 1, multiply, and that's 0. So 0 and negative 5 work. So look what I have here. So what I've got, this is just 5x minus 1. I'm just going to go ahead and set that equal to 0 and find the root. And if I do that, I'd add a 1 to both sides, and it'd be positive 1/5. So the answers are negative 1, negative 5, and 1/5. Those are all the places that the function would cross the x-axis.